This is Unit 4, Lesson 4, Comparing Data. And in this lesson, we will be learning how to describe data using measures of center and measures of spread. So we're going to go over some vocabulary terms first. First is measures of center, which is actually something we've already mentioned once before. Examples of measures of center are mean and median, and a measure of center can help us describe a data set. So the mean is going to tell us what is the average number in this list of data, which is usually about the center of the data. Median tells us what is the middle number in this set of data. For the most part, it doesn't matter if you use mean or median to describe the center. But if you have an outlier, meaning there's a number in your list that is much larger or much smaller than the majority of the list, then you would want to use a median. So for example, if I had the list 2, 2, 2, 3, 5, 5, 6, 9, 30. Finding the mean, we would get a number that's a little bit higher because this 30 is an outlier. If we do the median, then it will be a more accurate representation of all these other numbers in the list. So mean and median can help us find measures of center. We also have measures of spread. Measures of spread describe variance of data values. Or in other words, they describe how much the data values vary from one to the next. And there are two different measures of spread that we are going to be learning. The first one is mean absolute deviation. The mean absolute deviation is the average absolute value of the difference between each data point and the mean. So in other words, we take the absolute value of the difference between each data point and the mean. So if the mean is 5 and a data point was 3, we would do 5 minus 3 is 2. The absolute of every one of those values and then average them together. So as a reminder, absolute value means that the number is positive, pretty much. So if I have, these bars are absolute value, the absolute value of -3 equals +3. These bars on each side of the -3 make the number become positive. So if I have the absolute value of 5, that's just going to stay as 5. So if it's negative, if it becomes positive, if it's positive, it stays positive. We'll look at an example of mean absolute deviation in a minute, but first let's talk about interquartile range. Interquartile range is the last vocabulary term we're going to look at right now. It is the difference between the first and the third quartiles. So to find the interquartile range, I will do the third quartile minus the first quartile, and that's the range. If I am using the mean to describe my measure of center, then I'm going to use the mean absolute deviation to show the measure of spread. If I'm using the median to find my measure of center, then I'll probably use the interquartile range to find my measure of spread. Okay, let's move on and look at how we find the mean absolute deviation. So here I have two different hockey teams, the Ice Kings and the Gliders, and I have the number of goals that they scored at each game. Right now we are going to look for the mean absolute deviation. To find the mean absolute deviation, let's start out by reorganizing our data so it's all in order from the least to greatest. It's always a good idea to start out any statistics-related problem by just organizing the data least to greatest. So now I have all this data least to greatest. The first step in finding the mean absolute deviation is finding the mean. As you know, the mean is found by adding all the numbers together and then dividing by the total amount of numbers you had. I'm going to start out by just doing the Ice Kings only. So for the Ice Kings, when I add all the scores together, I get 30. And then I'm going to divide that by 14 because there were 14 teams. So 30 divided by 14 is going to give me a mean of 2.14. Now that mean is an important number. I do not want to forget the 2.14. Because the next thing I need to do is do the absolute value of the data point minus the mean. So I'm going to look at every single value that is on the Ice Kings list of goals scored. So the 0, 0, 1, 1, 2, 2, 2, 2, 2, 2, 5, 5, and 6. I'm going to plug each one of those one at a time into the data point, and then I will subtract the mean. So I'll start that off with the first number, that first 0, and I will do the absolute value of 0 minus the mean, which is 2.14. Well, 0 minus 2.14 is negative 2.14, and the absolute value of negative 2.14 is positive 2.14. Now I'm going to do it for the next value in the list, which is once again 0. So 0 minus 2.14 equals 2.14. I did it a third time because we have 3 zeros in the list. Now I'm going to do it for the ones. I have 2 different ones, so we'll do 1 minus 2.14. That will equal 1.14. And then I've done it again for the second one. Now we have 6 different 2's. So 2 minus 2.14 gives us the absolute value, positive 0.14. Now, I am kind of lazy right now, and I don't want to do that 6 times. So I'm just going to remind myself off to the side that I'm going to have that number 6 times in the end. So let's finish up the list and do 5 minus 2.14, which gives me 2.86. And as a reminder, I'm going to have 2 of those in the list. And then finally, 6, absolute value of 6 minus 2.14 gives me 3.86, and I'm only going to have 1 of those. So to find the mean absolute deviation, I have to find the mean, and then I find these 14 values that I just found. Try to circle them up. And next, I'm going to add all 14 of those together. That is why it's important to do the data point minus the mean every single time you see a number on the list. So I'll have 2.14 plus 2.14 plus 2.14 plus 1.14, and then we have 1.14 again, plus I'm going to have 0.14 6 times, and then 2.86 twice, and 3.86 to finish off the list. So we found the mean, we found the data point minus the mean. Now we're going to find the mean again. We add these numbers together and we're taking their average. So we'll add them together and divide by 14. When I add all of those numbers together, I get 19.12. And then I need to divide it by 14 since I added all 14 together, which gives me 1.37. So going through the process one last time, we find the mean from the original list. So we add these 14 numbers together and then divide by 14. Then we find the variance between each data point and the mean. So we do the data point minus the mean, data point minus the mean, data point minus the mean. And we do that for every number in the list. Then we take that difference, all 14 of the differences, we add all of those differences together and then divide by 14 since there's 14 numbers. So add it all together, we get 19.12. We're finding an average, so we'll divide it by 14, and that gives me 1.37. That is how I would find the mean absolute deviation. Now, normally I would also find the mean absolute deviation of the gliders, the other team, and I would compare them to one another. But for this lesson in this example, we're going to do the interquartile range instead. So here's that list of numbers again. This time I'm going to look at the gliders over here. And to find the interquartile range, I'm going to start out by first finding the first and third quartile. So to find the first quartile, I need to start out with the median. So my median is going to be, we've got 14 numbers, it will be the 7th and 8th number, which the middle numbers are 12 and 14. Or not 12 and 14, they're from the 12th and 14th game, which the middle numbers are 2. So let's split this set of numbers right here at 2. My first quartile is the middle of the lower half, and my third quartile is the middle of the upper half. The interquartile range is found by doing third minus first. So I'm going to do 3 minus 1, which tells me that my interquartile range is 2. So finding the interquartile range is much easier than going through this process to find the mean absolute deviation. But we want to know how to do both measures of spread because sometimes you need to use the mean absolute deviation. And sometimes what you need is the interquartile range. We'll go over more examples in class and talk about this some more, but I wanted you to have this first exposure to it where you're able to go back and watch again if you're a little confused on the mean absolute deviation.